Hi everyone, welcome to NCK Hub. Today in our video we are going to cover heap sort as part of data structures and algorithms. We'll see what is heap sort and how it works, and with sample program we'll see the execution. So what is heap sort? So heap sort is a kind of comparison based sorting technique based on binary heap and data structure. So heap is like nearly complete binary tree where parent node could be either maximum or minimum. So heap with minimum root node is called as minimum heap, and maximum root node is called the max heap. So first given elements in the input data are processed using two methods. So first we are going to build a heap from the input data using the heapify method. So what is heapify method? It is the process of rearranging elements within a binary tree to transform it into a heap data structure, ensuring that the tree is going to maintain the heap property where the parent node is always either greater than the maximum heap or less than the minimum heap. So yeah, if we feel like the child node is less than the parent node, then no swapping is required. If we feel the parent node is smaller than the child node, then elements will be swapped. So yeah, finally we are going to get the complete binary tree into like either a maximum heap or a minimum heap by using this heapify method. So what is heap sort algorithm? So first we are going to convert the array into maximum heap using the heapify method, and elements are going to be rearranged by following this heap properties. So one by one we are going to delete the root node of the maximum heap and replace it with the next immediate parent node, so whichever is highest, and then again we are going to apply the heapify process. So we are going to repeat this process until the size of the heap is greater than 1, and then we are going to rearrange these array elements so that they are going to form a maximum heap, and we are going to repeat these steps until the heap contains only one element. So we'll swap the root element of the heap with the last element of the heap. So whatever, since we are expecting that root element is the largest, and then we are going to swap it with the last element. So, and then we are going to remove the last element of the heap, so which is now it is in the correct position. So that's how we are going to reduce heap size, and we are not going to remove the element from the actual array. So and then we are going to continue this process, and then finally we are going to get the sorted array. So this is the simple algorithm. So we are going to implement the heap sort method, and then we are going to build the heap data structure, and this is like how we are going to build apply that heapify method. So we are going to swap the elements, and then we are going to apply this max heapify method, and then we are going to get the sorted array. So now we'll see how it is going to work. So with the given example, so first given elements are like this: 13, 4, 10, 15, 11, 19, 9, 24. So now we are going to sort these elements in the ascending order using this heap sort algorithm. So first we are going to form a binary tree with the given elements, like first given element 13 and 4, and then 10, and then 15, and then 11, and then 19 and 9, and then finally 24. So first we are forming a binary tree, and then we are going to apply the heapify method so that our parent node expecting a maximum heap, so that the highest number would be on the parent node. So yeah, so we have the 24 element here, and then we are going to compare it with its immediate parent 24 and 15. So we can see that 15 is smaller than 24, so we are going to swap these elements. So after swapping we are going to get like this 15 and 24, and then again we are going to compare this 24 with the immediate parent so that is 24 and 4. Again we are going to swap these two elements, 4 and 24, and again now we are going to compare this 24 and the parent like 13. So here 13 is less than 24, so we are going to swap this element. So after swapping this element, so this is the binary tree structure, and then again after 24, like we are having the next highest element is 15, so again 15 will be compared with 4, and again these two will be swapped, and then again 15 and 13 will be compared. So again this is how these two elements will be getting swapped, 15 and 13. So after that, immediate the right side of the binary tree, so we are having the 10 and then 19, 9. So here we are going to compare 19 with the 10, and then here 10 is less than 19, so elements will be swapped, 19. So after applying this heapify method, like now we are getting the 24 as the parent node. So now we are going to remove this root node 24 and keep it aside. So and we are going to replace this parent node with the immediate parent one. So here we can see from these numbers, like 15 and 19, our immediate parent is 19. So we are going to rearrange this binary structure again. So now 24 is going to be popped, and 19 is we are going to make it as a root. Okay, and it is the next maximum node. So again we are going to compare after swapping 19 with the root node, so we can see the elements 19 and next child elements 15 and 10, and then immediate 13 and 11, and then 4 and 9. So here we can see all are in so all the pair nodes are greater than its child. So yeah, so no rearranging is required further. So next we are going to remove this parent node 19, and then we are going to take the 15, so that is the immediate parent, and again we are going to rearrange the elements 15, 13 and 11. So right side of the binary tree we can see 10, 4 and 9, so those are all same. So again here no rearranging is required. So 15 is we are going to pop it, and then we are going to make the 13 as the next heap element. Okay, so 13 and 11 right side you can see 10, 4 and 9. So again we are going to place it here. So right side we can see like this, this is going to form the array like which are already in sorted 15, 19, 24, and then again 13 we are going to pop it up. So immediate parent is like 11, 11, 10, 4 and 9. So we can see, so similarly like we are going to pop the elements using the same process. So we are going to remove this 11, and then elements are going to become 10, 9, and then immediate child it's like 4. So here again we are going to pop the 10, and then we can see the structure 9 and 4. Here the root element is 9 and child is 4. So 9 we are going to pop it and again place it in the array, and finally like 4 we are going to place it. So that's how we are going to get the sorted array in ascending order. So coming to complexity, so the best case is order of n into log n, and average case is also same, and worst case is also same, n log n. So best case is like no sorting is required. Even in that case, like we need to check the same process, and average case is like when the given array elements are in jumbled order, so that no ascending or no properly ascending or descending. Worst case is like when the elements are required to be in sorted order. So space complexity we can say it's like order of 1. So now we'll see the sample example of this heap sort. So this is the main structure. So here we are just initializing one array with the given elements, whatever we have seen in the slide, and then we are going to get the length, and then before sorting elements, so we are printing the array, and then we are calling this heap sort algorithm, heap sort method, and finally after sorting, so we are printing the elements. So in the heap sort method, okay, so this is the heap sort method. We are passing two parameters, array and the size. So here we are initializing one for loop. Okay, so int I equal to n by 2 minus 1, I greater than equal to 0, I minus minus. So here we can see I is like, so array size is like 8, and then here we are going to get it as 3, 8 by 2, 4 minus 1, 3, and 3, 2, 1, 0. So like that it is going to iterate 4 times, and then we are applying this heapify method. Okay, so heapify, like we need to convert our given array into binary structure and then heap. So here we are considering that largest element is our root node, and then we are forming that left and right child. So here this is the left child, 2 into 1 plus I plus 1, and right child is 2 into I plus 2. So if we feel like left child is greater than right child, we are making it largest equal to left, and similarly if the right child is larger than root, so we are making that largest equal to right. So in case that root is not largest, like we are going to swap with the element with the largest, and then repeatedly we are going to apply this heapify method in a recursive manner. And similarly, so we are going to extract one by one element from the heap, and then we are going to move our current element to the end. Okay, so like this we are going to implement this heap sort algorithm. So yeah, we are going to print the elements like in the heap sort during the iteration. Okay, so here we can see int I equal to n minus 1, so that means array size is 8, so 7. So here these are the number of iterations. In each iteration we can see the changing in the elements. Okay, so during these 8 iterations we can see the how the elements are changing their positions. So I'll execute. So before sorting the array elements, so these are the elements 13, 4, 10, 15, 11, 19, 9 and 24, and similarly after sorting, so all the elements are sorted in ascending order. So during each iteration, so like we can see how the elements are changing their positions, 19, 15, 10. Okay, so after applying heapify method, so these are the nodes. Okay, 19, 15, 10, 13, 11, 4, 9 and 24. So like this we can implement this heap algorithm. So this is how it works. Yeah, thank you so much.